As we get started, today is the 30th. If you are the person who dates your notes, that is intelligent. And yes, for those of you who are so inclined, also remember that the 30th is Father Jim's birthday. So you may wish him a very happy birthday if you see him later. So,
The dog.
yeah, oh no, I didn't know that we celebrated it.
Oh, well, we were in class and a bunch of Spanish kids came in singing Happy Birthday in Spanish.
I'm pretty sure she didn't understand that.
Just some reminders, ladies and gentlemen. What do you owe me tomorrow?
Data.
So you need to give me data tomorrow.
Show you that we're like working.
Yep, I need progress. Data tables, typed data tables.
Type?
Oh, it has to be typed?
What if we don't have a lot of data yet?
Give me the start of your data in a typed data table. Remember what data tables are. Data tables are not graphs. Data tables are not graphs. Data tables are tables.
How do you start your logbook? Like, what should you write on the first page?
The date and what you did that day. So I am going to remind you, October 1st, that's tomorrow, right? If you don't give me things that you owe me before I leave, you will not receive credit for them. Have you all heard me? Remember last week I wrote, oh no, on this same PowerPoint to remind you. I am going to tell those of you who do not have a signed and approved experimental design, your last opportunity to do so is my last day here. That's up in the air. We don't actually know when that will be. It could be tomorrow. It could be the 15th. We have no idea. So, friends, if I have yet to see anything from you, I asked nicely at the beginning of the year. I poked, I prodded, I said I have equipment to loan. This is where your deadline becomes much, much more real. You should start getting very nervous. You should have been nervous last week.
This other teacher, does she know how to do science fair?
She is not responsible for any of your science fair.
If we have questions, though, who do we ask? Miss Carl?
I will direct you to your supervising teacher. And if I am your supervising teacher, I am only for a handful of you in here. I will probably have you go to Mrs. Carl. I don't see an adequate amount of panic here.
I'm calm. All I need to do is just go see Mr. Dudas and then I'm good. I have all my data.
Ladies and gentlemen, do you know what you owe me? Do you know why it sounds serious? What's your next due date?
The 11th. Tomorrow and then the 11th.
Tomorrow and then 1 week from tomorrow, right? Next Thursday. What do you owe me on that day? I do believe that would be the 8th. You owe me.
So that's when all your data should be pretty much done.
Next Friday on the 9th. On the 9th, you will be doing oral reports for your science fair. That means you are going to be standing up and telling everyone what you did, what you've done, what your project is, your independent variable, your dependent variable. And this should be easy because you already will have your data and your analysis.
What if like you have your baby sooner than the 11th?
Then we are going to have to adjust, but I don't think that's going to be a problem.
Because like would we do that with the sub then?
Nope. Here's what I will tell you guys again. The sub will take nothing from you for science fair. So if you don't have an approved experimental design, don't ask her. She won't take it. She won't sign off on anything. She has no training in it. She will look at you like she has no idea what you're talking about.
Well, that's not
She
good.
starts speaking like in a foreign.
So, who do you talk to if you need to?
Miss Carl.
You're going to talk to your supervising teacher for assistance, but they're not grading you. Every due date after graphs will be done for me when I return. If you don't have an approved experimental design before I leave, there's no way to get one.
The whole thing.
Because what if you come back in January?
I'll be back by then. Yeah, that's not a problem. We all understand?
I mean, everyone's in here is approved, isn't it?
Nope. They're okay.
Signing.
Next thing up.
It was 6th.
So we went through all of our science fair due dates.
Yes.
You have a vocab assignment. Your vocab assignment is going to be due Monday.
Doesn't it even feel like Wednesday?
You will have a quiz on Monday. Your vocabulary must be handwritten. It may not be typed, and you do attach it when you use it on your vocabulary quiz. Yes, just like you're accustomed to, you staple it on for your vocab quiz. Yep. Just the vocab. So your job is to do that vocab for Monday. Remember, not typed, handwritten. If you want it on note cards, you may turn in a stack of note cards. We'll just put them in an envelope and attach them that way. Some of you prefer using flashcards so you can use them to study for your tests. Totally fine. I don't blame you for that.
Where are you going to give us like a list?
Yep, I gave it to you after your quiz.
Oh. So like number
You
one.
wanted to see
Signature.
just so I know what to give you.
Yep,
Sometimes we draw.
every single one. Okay. That's that. So, over the course of the last 2 academic days, we looked at aluminum foil. We looked at an index card. And we looked at copper 2 chloride. And I had you make observations. Tell me what some of those observations were. For aluminum foil, let's see. Jacob. Tried to light it on fire and it didn't. What else?
Doesn't like the color is
There's no color change, so it remained what color?
so
It does conduct heat.
Can I go find that hammer?
I threw it away.
Oh, really? Do you have a new one? No?
And what else? What happened when I balled it up and then struck it with a hammer again?
What?
Still shiny, but it flattened, right? Into a sheet?
Yeah.
So it's malleable? The index card. Did it combust?
Yes.
Was it shiny?
No.
Did it conduct heat?
Was like 1 out of 5.
Does not conduct heat. I don't want to have to take phones.
It's reacting to heat.
But does it conduct heat? If one side of my index card is on fire, if I touched the other side, is it hot?
No.
Can you hold a burning piece of paper?
No.
Yeah.
Oh yeah. Oh.
It would just
Yeah.
go in your hand.
The other one that.
It would eventually burn down to your hand, right?
But the part doesn't.
But it does not conduct heat.
So no.
Was I able to change its shape?
Yes.
So it could be torn. It could be crumpled.
He wanted.
The copper 2 chloride. What color was it?
Blue. It was a liquid.
Is it big C, little U, big C, little L?
Yeah.
What'd you do with your broken hammer?
Threw it away.
You broke it?
Mm-hmm. And it bubbled when I added it?
Yep. The aluminum foil turned brown.
How about looking at that experiment from the reverse? What happened to the aluminum when I added it?
Turned brown. Turned like a reddish color.
It turned like a red copper color when we added it to the copper 2 chloride? You agree? It definitely eroded, so it got smaller and smaller and smaller.
I don't think there was less liquid after that.
Reacting.
So it reacted with the blue chemical, right? The what you guys called blue Powerade. It reacted with it.
It stopped reacting because it ran out of blue chemical.
It did slow down in reacting as it ran out of blue chemical. A couple things slowed it down. As the surface area of the aluminum disappeared, of pure aluminum, it became slower. And as the unreacted chemical decreased, it became slower.
What's that thing under index card says torn,
Crumpled. Yep. When you add aluminum and bubbled.
So if you have like if you put it into like a bucket of that blue stuff and just kept on stirring it, would it just
Keep reacting until it was all gone.
Change color when you had.
The observations that you've made here are all what we call properties. When we study chemistry, as you guys defined chemistry already, we said that we study matter and the changes that matter undergoes. So the first thing we do as chemists is describe matter. Was that particularly challenging? To describe the properties of matter? You had a hard time with it?
You always say that one question. Why?
Did you do the field test like you just had to write the word and then all the stuff on the side?
It's like last year's.
Every one of these properties was macroscopic. What does macroscopic mean?
Really small.
Wait. What did you say macroscopic was?
The tiniest that can be. Can't be seen by the human eye.
Is it microscopic or?
Oh, is it microscopic or macroscopic? Everything you described, did you need a hand lens or microscope to see it?
No. So it's big enough to be able to destroy.
Macroscopic means big enough to be observed without any aid. So large enough to be seen by the naked eye. Now, if I've written the word down, what should you do?
Write the word down too. Write the word.
So everything you described for me watching those 3 demos was macroscopic, visible to the naked eye. And that's where chemistry starts. We always observe the properties of matter that are visible to the naked eye. There are 2 kinds of properties that you defined for me today. Physical and chemical properties. Physical properties, you can determine them without altering the substance. So I can figure out anything's physical property without having to change what the thing is made out of. So it can be observed without altering the substance. Chemical properties are observed when you have a change in composition. So they are observed with a change in composition. So let's think about that list you made for me. What was the first thing about aluminum? Not combustible. Is the ability to combust or not combust physical or chemical? What was the second thing we said about aluminum?
Shiny, silver, luster.
So shiny, is that physical or chemical? Can I observe shiny without changing anything? Silver. Can I observe silver without altering? So is that physical or chemical? Luster. What does it mean to be lustrous? Lust is a deadly sin, but luster is simply a characteristic that means ability to reflect light. So, how did I define luster? How did I define luster? Did I say shiny?
No.
What's the textbook definition of luster, Jack?
Nope.
You said dull, and then like after the card, so would that mean like it's like a, yeah, I'm lost.
It is the ability to reflect light. So if something is lustrous, it can reflect light. Is that physical or chemical? What was the next thing that you said, Tyler? On your list after luster?
What? What did I say?
On that list we made together.
For what thing, aluminum?
Mm-hmm.
You can like make easily bend or shake.
I was not on the list.
That was on the list, right?
No.
Oh yeah. Malleable.
Malleable.
So what's the next one, not what's the last?
Is malleable physical or chemical? When I call on someone who hasn't raised their hand, in teacher school they call that cold calling. Do you know why we cold call?
Because you're cold.
Why do we cold call? Not why is it called cold calling. Why do we cold call? Yes, indeed, friends. So what am I trying to tell you if I cold call on you?
You're asleep.
Don't worry, it was only because I knew you could handle it, friend.
He was actually wrong. You said what's the next one, and he gave you the last one?
So what is the next one?
It was conductive.
Conduct heat. Is that chemical or physical? That's a tough one.
No, it's chemical.
How many of you think the conducting of heat is a physical property? How many of you think conducting heat is a chemical property? Why?
Because it has to react with one other thing to actually have conductive heat. It's a,
Did it change the composition of the aluminum when it conducted heat?
No, it made it warmer.
It made it warmer, but did that change go away?
yes.
And when that change went away, was it still pure aluminum that remained? So does that make it a physical change or a chemical? And how about this? It turned red copper.
That was a chemical.
Was that a physical property or a chemical property? Qualify as physical properties are typically descriptions of color, odor, shape, size, and states of matter, right? What are the states of matter?
Can you go back?
Yeah. Solids, liquids, gases, and plasma. Oh. Are solids of a definite volume? Do solids have definite volume? Do solids have definite shape? Are solids squishable? Are they compressible?
Yes. Some.
Depends on the material.
Do we add the P?
It was like one of those stressful. Yes.
We generally consider solids not compressible.
Yeah, that doesn't really make sense.
Most of the time, if you take a solid and compress it and it takes up less space, what you've actually done is removed any gas that had at any point in time been mixed in. So like, you guys would think a sponge is solid, right?
Yeah.
And if I took a sponge and I squished it, did I really squish the sponge or did I just force the air out of the sponge?
Or water.
That makes you so different.
Well, water, solid water we call what?
Ice.
Okay. Have you tried to squish solid water?
It doesn't work.
Just breaks.
It breaks, right? Liquids are liquids of a definite volume.
Wait, so you're saying you can't squish a solid? What about rubber?
Wait, what does S mean?
It's going to return to its, once you relieve the pressure, it returns to its shape.
What's S
What
mean?
about
Solid.
No, Play-Doh does. No.
But it still takes up the same volume, right?
Oh, so you're saying you can't squish something and make it less volume?
What does P mean?
Plasma. Liquids, do they have a definite volume?
Yeah.
Yes.
Do they have a definite shape?
No.
What do they do?
They take the shape of what you put them in.
And can you squish a liquid?
What do you say shape of container?
Yep. So it takes the shape of its container
Can I use the bathroom?
and it is not compressible. Liquids.
Can I try it?
You're not going to get very far,
Oh, yeah.
but I mean,
Now, what if,
Just
like,
start-
can't you, like compress liquids and they turn into gas?
Wait, see this liquid?
If I compressed a liquid, would it turn into a gas?
Well, I've seen that happen before.
Or is it if you compress a gas, it turns into a liquid?
You ever like take one of those water bottles and twist it and let the cap out and like steam comes out? The liquid goes from the jazz.
Oh, you
That's
twist.
Oh, can I try that?
Or like when you
Dylan,
It
that's
just makes
mist.
it pop.
Oh, yeah.
It's not steam, it's mist.
You know, like in lava lamps, how they change shape? Like this is changing shape too. So this does, like, define shape.
So, well, it changes shape. Does it have a definite shape? Like if I took it out of that square, would it remain in that square?
No.
It'd run all over, right? So they don't have any given shape. Gases. Do gases have a definite volume? Do they have a definite shape? Are they compressible? Gases are compressible. Take a balloon, fill it with air, and then try and squish the balloon.
Yeah, but the balloon is something that's compressible, not the gas.
If the gas weren't compressible, the balloon couldn't compress, right? We can show you the change of, or how squishable a gas is if we simply put a balloon in a vacuum. If you decrease the pressure, what happens to the balloon?
It expands.
It's smaller. Wait, decrease? Oh, expand.
Yep, so if you put it in a vacuum and then you remove pressure, it's going to get bigger, right? We can do the same thing with something else that's pretty much full of air. I will not have time to go to the grocery store this afternoon, but if somebody goes to the grocery store and gets a container of Peeps, we can try that. Yep.
Like the candy peeps?
Yeah.
Don't they only make those during Easter time?
They have pumpkin and ghost shaped ones out right now.
Wait, if we bring one of those in, what would we
If you can compress gases or expand gases. Those are all of your physical properties.
So like, you know how like, when you put a marshmallow in the microwave, is that like, when it's expanding, like is that kind of like what it is? Like the gases being like it's getting denser and the gas like makes it expand
Wait, if
more.
we don't get people marshmallow work,
Yeah, will marshmallows work? I have
Yeah.
marshmallows.
Marshmallows will work.
I'll bring them.
So you're saying, hold that thought for when we do changes instead of properties.
all right.
So what is plasma?
gas?
It's ionized gas, so it has,
Same problem.
Wait, we never did the plasma.
it's ionized gas, so it's not especially exciting.
So just no, no, no.
No, yes. Chemical properties. Observed when there is a change in the composition. So it is only when there is a change in composition that we're going to see them. What kinds of things did we list from our list that were chemical properties?
The aluminum changing fire.
So something combusting,
The aluminum changing.
something reacting, chemical properties typically describe the ability of something to undergo a chemical reaction. So they describe the ability of something to undergo a chemical reaction.
Does it say combusting, reacting, or?
Reacting, yep, combusting and reacting. You will notice that chemical properties tend to sound more like verbs. Combusting, that's a verb. Reacting is a verb. Changing in color is a verb. But odor, color, those are descriptors that are physical. They're not verbs. They're not active. So that's kind of one way to think about it. Yeah, that's good. You and a